Okay, guys, thank you for joining this fine Wednesday. We're going to go over using Creo to manipulate CATIA models, of course, presented by Boundary Systems. All right, so we'll do a brief introduction of myself and Boundary Systems, and the topics that we're going to cover will include why we need Creo Unite. We'll do an overview of Creo Unite. We'll go over Creo Unite and Flex Modeling Extension and how it improves multi-cad collaboration. We'll go over Creo Unite and Flex Modeling Extension and how it supports CAD consolidation. What is Creo Flexible Modeling Extension? Why do we need flexible modeling? Creo Flexible Modeling supports late-stage changes. How Creo FMX supports multi-cad design, and how Creo FMX supports model prep and simplification. And then at the very end, we'll do a demo and then some Q&A. So my name is Bill, and I focus in industrial design and rendering. Boundary Systems, the company that I work for, is a tech leader. Some partners of ours include PTC, eTraj, and others. We are one of the 16 fastest growing private companies in Cleveland, and we are a part of the PDSVISION group of global companies. Some capabilities of ours include PLM, CAD design and consulting, simulation, and product development. Some awards of ours are the Inc. 5000, Weatherhead 100, and some major accreditations are the PTC Platinum Partnership, Windchill Certified Implementer, PTC Preferred Service Provider, and the PTC Authorized and Certified Training Partner for Creo, Windchill, MathCAD, and Arbortext. We offer solutions for PTC, Tacton, Moldex 3D, Xformation, eTraj, ITI, ZWCAD, Keyshot, Sigmaxim, and Cimerix. So the first thing to start off with is, why do we need Creo Unite? The first thing is, we need Creo Unite to help consolidate CAD systems to improve quality, speed, time to market, and lower costs for both engineering and IT. So one of the things here is consolidation. Best-in-class companies are 35% more likely to standardize on one CAD system. 59% of people have difficulty manipulating imported models. And as far as collaboration, it supports more effective product development and drives on-time delivery by working more efficiently with other departments, suppliers, or development partners. So why do we need it? The need to improve multi-CAD design, collaboration, and support CAD consolidation. So a lot of times there's an inability to directly open and work with non-PTC files. There's a struggle to collaborate and share multi-CAD data with design partners. There's a reliance on multiple CAD tools to collaborate and work with multi-CAD data. And oftentimes there's lost engineering effort moving data and switching between CAD tools. And also there's a lot of times wasted engineering time recreating geometry to implement change, and often an inability to reuse and repurpose legacy data and non-PTC data. So an overview of Creo Unite technology. You can import common 3D CAD formats, including SolidWorks, CATIA, NX, Solid Edge, and Inventor formats. You can open key 3D formats again. You can open up SolidWorks, CATIA, NX formats, and an Inventor with Creo 5.0 and later. You can automatically update new versions of non-PTC Creo data within your designs and save as key 3D CAD formats such as SolidWorks, CATIA, and NX. You can use the Creo Flexible Modeling Extension, also known as FMX, to make fast, flexible edits to any 3D CAD data in Creo Parametric. The complete solution combines Creo Unite technology and Creo Flexible Modeling Extension. Also note at the bottom, Unite technology can be used with other standalone apps such as Creo Simulate, Layout, Options, Modeler, and Creo Direct. Creo Unite and FMX improves multi-CAD collaboration. So what this means for you, you can open non-native files seamlessly, which allows you to avoid the need to recreate or rework design from other CAD systems. Modify geometry easily manipulate and add intelligence to models with other CAD systems, and maintain associativity. You can receive updates to models changed in their original CAD systems, and they are visible and propagated to Creo. So again, to the right, why it matters. This reduces time spent recreating existing data due to difficulties importing and modifying non-native models. And also there's a note there at the bottom, 59% of people have a hard time manipulating imported models. Creo Unite and flexible modeling extension supports CAD consolidation. What this means for you, you can seamlessly reuse legacy 3D data and eliminate the need to maintain separate systems. This helps convert data as needed. There's no need for expensive non-value added data conversion, and you can recognize and add design intelligence and use it to modify models. So what is the Creo Flexible Modeling Extension, also known as FMX? Creo Flexible Modeling Extension is included functionality with every Creo Essentials and Creo Engineer package. This tool provides powerful direct modeling capabilities to rapidly edit and make unexpected changes to parametric and non-native CAD data. So we have 3 images here to the bottom. The first to the left mentions that there's often unexpected last-minute changes. So FMX will allow you to make those last-minute changes. It allows you to work with multi-CAD data, so whether it's SolidWorks data, CATIA, NX. It also helps you to simplify models for simulation optimization. So again, just why do we need it? Users often struggle to support or often struggle to work with multi-CAD data and implement fast, flexible design changes. So people are used to sometimes are slow, difficult processes to recreate geometry to implement changes, implement late stage and unexpected changes, make changes to imported and non-native CAD data, simplify and prepare geometry for analysis and downstream activities, and evolve legacy and carry over geometry to support concept and detailed design. Creo Flexible Modeling Extension supports late stage changes. It enables you to make fast, flexible edits to geometry from any CAD source. So you can make fast changes to parametric geometry without having to rework design intent. You can directly edit and make changes to imported non-PTC geometry. It helps to eliminate wasted time rebuilding geometry to implement changes. Also, Creo FMX supports multi-CAD design, allowing you to easily import and work with data from other CAD systems. So you can easily work with and edit data from any CAD source, whether it's SolidWorks, CATIA, NX. You can parameterize obsolete design intent and add intelligence to imported data, and collaborate and share data with suppliers, partners, and the extended team. And Creo FMX also supports model prep and simplification. So you can easily simplify and prepare CAD geometry to support downstream processes, enabling users to de-feature models for downstream functions such as analysis and manufacturing. You can allow users to easily edit and modify geometry to encourage design reuse and support evolutionary design, and empower non-expert CAD users to prepare and work with CAD data. All right, so now we're going to get into the data. So we'll switch to Creo here. And what we're going to do is we're going to open up a CATIA assembly. So we'll open up this Petal 1 CATIA product. All right, so here we are. So we've gotten the CATIA product from a supplier or a vendor and open that up within Creo. And I'll just reposition this. So also notice that you can see it looks a little bit differently here. We have a different symbol for the models and the assembly referencing CATIA. So what we're going to do is we're going to now go into the flexible modeling extension, FMX, to modify this model, right? So the first thing that we're going to do is we're going to select a component or a body. So with Creo 7.0, also know that we have the ability to work with bodies, which prior to 7.0 we couldn't do. So we'll come down here into our selection filter and we'll select body. Then from here, we'll select the component. So we'll grab this component down here and we'll select show. And we'll also activate that component, the assembly. So what we can do here now is if we move to the flexible modeling tab, I can use what's called a pattern recognition feature. So up here in the ribbon, I can select that. And if I select one of these holes, right, you can see that it actually recognized the pattern. So we have a pattern with one pattern number here. So here's 1, 2, 3, and 4. And we'll click OK. So we've recognized that pattern. And what that enables us to do now is, say, for instance, that I want to modify that hole size, right? So I can select that hole, grab that cut feature, okay? Then up here, I can go to modify analytic, right? And we get a window saying you are about to make design changes to the model. These changes will not be reflected in the native model. Please use copy if you want to convert this model to Creo model and apply these changes. So we are going to do that, and take note that we can also, using Creo Unite, we can save this out as a CATIA product, and then anybody using CATIA can then bring this in. So with that being said, we'll click OK. All right. So right now we see that we have to specify the surface to modify. So we'll select the surface of that hole. And you can see it actually grabs that whole, the whole surface, right? And what we can do is, if we don't want to just modify and change that one hole as far as the size of the hole, if we want to grab all 4 holes, what we can do is we can go to options, then we can choose propagate to pattern, right? So what this allows us to do is, if we click in this field, we can go back to that pattern recognition feature in the model tree, right? Select that, okay? It adds it to that field, and what that enables us to do is to change not only just that individual hole, but every hole in the pattern. So from here, I can increase the size from 4 to 6, for example, right? And you can see that it not only changed the size of the hole for that individual hole, but for all 4 holes. We'll click OK. All right. Now, if we want to move all 4 holes, we can repeat the same process, right? So what we'll do is we'll go to pattern recognition. We'll select one hole, all right? Click OK. And then now I'm going to grab that hole, grab the hole cut feature, all right? And we're going to say move, and we'll change this from move to move by dimension. All right, and in options, because we created that second pattern recognition feature, we can select it, and that will enable us to then, if I go to here to dimensions, I can say, hey, I want to move relative to the center of this surface. There, and that surface, right? And that enables us now to dimension this, because we can dimension now from the center of that hole to this flat surface here. And let's move this from 40 to 45. Click OK. So basically what you're doing is you're taking this CATIA model and using flexible modeling extension, you're able to then take that assembly, which basically contains dumb solids, right, and then featureize those components. So every feature that we've created using FMX is showing up underneath this component, right? So you can see that these features are here. We have pattern recognition 1, right? We had that modify analytic, which allowed us to change the size of the hole. We did a second pattern recognition. Then we moved and applied that pattern recognition 2 to the move, which enabled us to move all 4 holes, okay? So just like any normal feature that you create, with inside Creo in the model tree, after you create these features using FMX, you can go back in there and edit those, right? So if I wanted to adjust the move of those 4 holes, just like a normal feature, I can grab that propagation of move 1, I can say edit, right? And then from there, you can see I can change that distance, right? So if I want to change it from 45 to back to 40 or to 35, I can do that, right? So let's change this to 50, enter, regenerate, and there it is, those holes move, okay? All right, so the next thing that we'll look at is offsetting a surface. So what we'll do is we'll come back here, we'll go to flexible modeling, all right? We'll select that surface, and then from here we have move, and then the second option to the right is offset. We'll select that, okay? And then when you use offset, that enables you to enter a dimension to offset that surface. So from here, I'll change that to maybe 10. Click enter. All right, that's a little bit too much there, right? So let's go in here again, choose that surface, and we'll change that to 2. Click OK. And we'll also come to this side, select that surface, offset at a distance of 2. Click OK. And again, because the offset is a feature in the tree, that enables me to, go back and change that dimension. So I can grab geometry 1, click edit, and I can change that from 2 to 3. Right? Then same thing here as well. Let's go to edit and change that to 3. Okay. All right. So now we'll take a look at drafting a surface. So let's show the rest of these components here. We'll just unhide all. All right. So say that we want to draft a surface. Let's grab this body, and again, we can go to our selection filter, bodies, select the body that we want. We'll do show only, and we'll move to first, let's activate that component. So we'll grab that there, activate it, go to flex modeling, and then from here, we can actually even draft the surface. So what I'll do is I'm going to go to the move tool, okay? Click OK. So from here, it needs a reference or multiple references. We'll grab that surface, hold control and grab that surface. And what's nice is I can grab or I can change the pivot point. So you see that we have the origin for these transitional and rotational handles. So I can grab the origin and then click this bottom edge here, right? And now what I can do is I can use that as my pivot point and then rotate that out and draft that surface. So I'll change that to 2. Click enter. All right, so let's draft it out, and we'll grab this side now. Click in the origin field, grab this edge, and we'll rotate that to 2. That looks good. And click OK. All right, now we're going to show all again. So we'll go back to view, unhide all. All right, and now what we'll do is we'll actually activate one of these knobs here. All right, so to do that, we'll change this from geometry to body. And let's just grab this one here. We'll show that, activate that component. Let's move to the flexible tab. All right, so what I want to do here is I again want to use that pattern recognition feature to enable me to reduce the amount of extrudes here or pattern members on these extrudes that we see on the knob. So the first thing that we'll do is we'll go to pattern recognition. All right, I'm going to grab that surface, right? And we see that we have showing us 8 instances, spacing 45 degrees. Now, in order for me to edit this to change the number of pattern members and the angle, right, I can go to options and I can check the allow edit box, right? Then from here, if I want to reduce the number of pattern members from 8 to 6, I can change that from 8 to 6. And then I'll adjust the spacing as well. You'll see that, we reduced the pattern members. We had a pattern member here and here before. Now we only have 1, 2, 3, 4, 5, and 6. But we want equal spacing because we want this thing to go all the way around, 360 degrees. So let's change this from 45 to 60. Click enter. All right. And now when we click OK to complete this feature, we should see a reduction in the number of patterns. So let's click OK. And there it is. All right. You can see that too, right? We see we have a deduction. We have a reduced number of pattern members compared to the knob below it. Okay. All right. So now what we're going to do is we are going to recognize a round feature and change the radius. And again, from here, I had this component activated in the model tree. If I want to, I can go back to that feature. I can say edit, and change the number of members. If I go to edit definition, I can adjust the instances, change the angle, just like we would normally within Creo to adjust the features. Okay. So now we'll go ahead and change the selection filter to part. We'll grab another body. We'll grab this body here. All right. Activate that body, right? And then move back to flexible modeling. Then once we're here, we can use a tool known as modify analytic, right? And if I select that, I can grab a round, right? And what this enables me to do is change the size of the round. All right. So if we want to, decrease the size of the round, increase the size of the round, we can do that. So let's try increasing it, right? So we'll bump it up from 5 to 6. Enter. But notice that when we do this, it's increasing the round, but the adjacent surfaces aren't attached, right? And that's because we're not maintaining tangency to those surfaces, right? So if we go up to the dashboard, I can click on this button, which says keep existing tangency to surfaces directly adjacent to geometry that is being modified, right? Now, if I select that, you'll see that now we have a nice smooth transition here. Everything that's tangent increases in size. Okay, and we'll click OK, and there it is, right? And again, if I want to go back into that component, I can grab that modify analytic feature, click on edit, and maybe you want to decrease this, change that to 4. You can enter in 4, hit enter, regenerate, and there it is. Okay. Okay. The next thing that we'll take a look at is, using this CATIA model, these components, these bodies, and the CATIA assembly, and maybe grabbing one component and converting that to a sheet metal component, right? So what we'll do is I'm going to go to bodies again down here in the selection filter. I'll grab that component, and then with bodies now I can grab that body one. I can right click and I can say construction. Why isn't it allowing me? Let's activate that first. Right click, so activate the component first. Select the body, right click, and now from here we can convert to a sheet metal part. Click OK. And we'll define the surface. And we'll also remove the adjacent rounds and chamfers. Click OK. And then now you can see we've converted this body to a sheet metal part. And now this brings us into the sheet metal interface. And we can now add a flange. So the first thing that I'll do is I'll go into flexible modeling, and I'll grab this round. And notice also that when you're in sheet metal mode, the interface of flexible modeling changes, right? So the features that you see here change quite a bit. It now references flexible modeling, right? So because we're in that mode, now we have the ability when in flexible modeling to pull a wall, edit a bend relief, edit a corner relief, edit a corner seam. So we see things here that are related to sheet metal. But one thing that is common to the flexible modeling extension within sheet metal and in normal part mode is that we have the ability, if need be, to remove rounds. So if I select that round, I can grab remove, click OK, and now that round is gone. All right. So what I'll do here now is that because I'm in sheet metal mode, I'm going to kind of grab an edge and try to match the wall feature, the sheet metal feature that we see here. So I can go back to sheet metal, right, and grab an edge and create a flat there and adjust that, right? It will change the bend position and the radius. Make that 5. Okay. We can unbend, then add a radius for a round. All right. So let's grab that. Let's increase the size and make that 10. Then down here as well. All right, that looks pretty good. Let's click OK. And I'll add one more round here. Spin that back. Okay. All right. And also notice too, again, if we go back to the flexible modeling tab, we have these different options. So if we want to modify the bend, the relief, corner, if we had a bend relief, we don't have one in here now, but we have these options to modify that, right? Okay. The last thing I want to show is the ability to offset or to move a surface and actually just create a surface that's offset from the original, and then create like a rib using that surface. So let's go back to body. Let's grab that component. All right, we'll activate that component. So from here, so previously, right, if I move back to flexible modeling, I can grab a surface like this. I can choose move. I can choose to move that surface, but I also have the option to, if I go to attachment, I can choose just to move that surface itself, right? Instead of moving all the geometry, right, of that solid, I can just create a surface and move that surface. And to do that, I can go within the attachment tab. I can deselect the attached moved geometry box, okay? And that just creates a surface, right? I could also change this to edit by dimension, right? And I can say, hey, let's use that surface, and then offset this by a dimension. And of course, you would probably want to get the exact center, or, we're going to actually extrude normal or thicken normal to the surface. So you'd have to calculate that, using the measurement tool to kind of get it exactly centered. We're not going to do that here. We'll just use this for an example. So let's move that back a little bit. Click OK. So now you can see that we just have that surface, right? And now if I want to, I can go back to model. I can grab that surface and choose thicken. And then from here, I can move that out. Let's change that to 10. All right, that looks pretty good. All right, now one thing to mention here is that if I unhide all, we can see that we have some interference here with that new rib that we're creating, and here as well. So we can continue, right, using FMX to modify this. So what I'll do is, and also because we're in Creo 7.0, I can go back to thicken, I can go to edit definition, body options, and in body options, I now have the ability to create a new body. All right, so this new body will be separate from this body here. Okay, and that enables us to do a couple things. Let's click OK. All right, and we'll move to flexible modeling. All right, and now once we're in here, there's interference here, and I actually want to bring the rib back here. So what I'll do first is I'm going to go to remove, and I'll select that surface, this surface, and that surface, right? And you know what, let's grab that surface as well, click OK. Now, because this is its own body, when I move this face, right, it's not going to try to move this surface as well because it's its own body. So I can go to move, I can grab that surface, and I can pull that back, okay? Click OK. I also like the fact now here as well that I can draft this, right? So this isn't an ideal, there's an undercut here, right? So, I can grab this surface, I can go to move in the mini toolbar, and I can change the location of this translation node, right? So in the origin field, I can select there. I can change the origin from the center of that face, that bottom edge, and now I can draft that back, all right? So I can change that, and I can make that 65, for example. Okay, all right. We still have interference here with the pedal, right? You can see that they intersect each other in this area. So from here, I'll activate the top level of the assembly, and I'll go to an extrude feature, and we'll sketch on this surface. Grab a cross section here, and then maybe we'll grab, this bottom edge. We'll put a solve. Now we have it partially placed. What else do we need here? Let's go to planes. Grab a plane, and we'll grab This plane here, solved. Now we're fully placed. We'll hide these planes, right? And now from here, what I can do is I can cut out where the interference is here. So let's go to center rectangle, and we'll just draw one in there. We'll extrude that and remove the material. Click OK. All right, looks like we have a slight problem here because it cut out a portion of that rib, but we can fix that, right? So you can go down to that extrude feature, edit definition, and then go to intersection. Right click that, deselect the automatic update and go to remove. Click OK. And now that rib is intact. That's fine. All right. But now, we actually have to merge that. And using Creo 7.0, we have multiple bodies, and we can also merge those bodies, right? So what I'm going to do is I'm actually going to select this feature here, activate. All right, and I'm going to grab the flexible modeling tab, grab that round. Let's go to remove that round. And now I have to align this surface with this surface here. All right, so we'll grab this guy. It will say move by dimension, grab that surface and that surface. And now we see it's offset 0.4. These need to be 0 to be aligned. So we'll change that to 0, click OK. And also we have a space between this flat surface and this surface. So we'll grab that, we'll say move by dimension. All right, we'll grab that surface and that surface, and again we have 0.4. Let's change that to 0. Click OK. But now we have to merge the bodies together, right? Oh, but also note that when we offset this surface, match this surface, this round isn't tangent to the surface. We can fix that, right? So let's go back to this move right here, edit definition. At the very top, we have maintain tangency or keep existing tangency. If I select that, click OK, now we're good, okay? So now from here, we're gonna go to regions and surfaces. We'll go to body. We'll select that body and that body. All right, let's go to the model tab. That body, let's change the body again. That body and that body. And now we have the option, right, to merge those bodies. Click OK, and now those two are merged. And then from here, if we want, right, we can grab a round and add a round there, so on and so forth. Okay, let's reactivate the top level. Okay, unhide all. Let's activate the top level. All right. So you can see here that, we've done quite a bit of work, but, we were able to take that native, CATIA model, bring that into Creo, made some modifications, right? And then from here, we can save that, or, we can also do a save as. If we want to save it as a different, part number, that's a CATIA assembly, we can do that, right? So we can go to File, Save As, save a copy. We can change the type to CATIA product. All right, we'll call this pedal 2. You can see it's processing down here. It says the CATIA 5 file pedal 2 product has been created. And then now, you can share this model. One thing to note too as well is that, if you have the original file and, changes are then made in the CATIA software, if you import that, those changes made in CATIA will also update within Creo, okay? All right, So with that being said, let's go to the Q&A. Before we do that, I'll just, again, just go over, my name is Bill. Feel free to contact me at my email. If you have a question, concern, or whatever it is, get a hold of sales. Also feel free to visit us at our website and our YouTube channel as well. All right. So if you guys have any questions, feel free now to ask. All right, I don't see any questions. Also take note that, if there's something on here that you want to go over again, that you forgot, or that you want to show your coworkers, friends, feel free again to visit our YouTube channel. This video should be posted today at some point, or tomorrow. All right, thank you for joining.